All right, and time for the final section of this unit. This is for law of cosines. So now we are again solving triangles. We do not have a right triangle, so we're not going to solve it that way. We do not have a triangle where I can use law of sines. Instead, I have either all three sides or I have a corner. Okay, so I don't have a whole piece of the law of sines. So on here, bell work wise, we're going to do this triangle and we're going to use law of sines again just to reiterate that concept. So working this out, okay, we're going to call this angle C because it's 135 degrees. I know side C is 100. And we're going to call this side B. So we need to find angle B, angle A, and side A. Okay, we don't have that situation where I have two of the angles so I can find the third angle, so I'm going to have to set up law of sines first. So sine of angle A, which I don't know, over side A, again I don't know, is equal to sine of angle B divided by 15, which is equal to sine of the 135 over 100. Okay, and again with law of sines, you're going to have one fraction that we can go ahead and use because we have both pieces, and then we have one fraction where I'm missing only one piece. Okay, so we're going to use those last two here. Okay, we're going to cross multiply, so I have 100 times sine of angle B is equal to 15 times sine of 135. We're going to divide both sides by 100. And again, here I have to get rid of that sine, so I cannot just divide by sine. I have to use the inverse sign to get rid of sine. So I have sine inverse of the sine of B is equal to the inverse sine of this, so 15 sine of 135 over 100. And again, what happens here is the inverse sine and sine will cancel. That will leave me here with angle B to be approximately 6.09 degrees. Okay. Using that information, then we're going to try. We're going to work and solve for angle A now, since it's the only other angle missing. So I have angle A is equal to 180 minus the angle B minus the angle C, which then now we have angle A is approximately, again because angle B is rounded off, 180 minus the 6.09 minus that 135. So angle A is approximately 38.91 degrees. Okay, so now again, I'm going to go through and come back up to here. I'm going to erase this A now because now we have a value for it. It's 38.91. Okay, we're going to utilize now then again that last fraction because it's whole, and then I'm going to use the first fraction here. And again, I'm going to multiply, cross multiply. So I have A times sine of 135 is equal to 100. Sine of the 38.91. I'll overlap there a little bit, sorry about that. I'm going to divide both sides by sine of 135. Again, plugging this in the calculator carefully, you should end up with A is approximately 88.83. Okay. Moving on to the actual notes here. We only have a couple pages here, so it's going to be pretty quick. Okay. This page, law of cosines, you'll notice that are three different setups. Notice they are very, very similar to each other. The only difference is what is in front and what is at the end. Okay, so pay close attention to that. You have a squared equals b squared plus c squared. So one side length is equal to the sum of the other two side lengths squared. Okay. Minus 2 times the 2 that's on the right hand side times the cosine of the angle that is the uppercase or the opposite angle of the side that is on the left hand side. Okay, so again, make sure you pay attention to that. That sounded kind of weird, but these are pretty easy to remember if you work with them a couple times. Okay, so b squared equals a squared plus c squared minus 2ac times cosine of angle B. Notice the only thing that changes here, side B and side A switch spots. Okay, so anywhere I saw an A up top in that first equation, the lowercase a, it was replaced by lowercase b. Anywhere I saw lowercase b, I replaced it with lowercase a. And now since angle or side B is on the left, then angle B is at the tail end. Okay, and similar to the bottom there, c squared equals a squared plus b squared minus 2ab times cosine of c. Okay, so pay attention to those. Okay, when you use law of cosines, you use law of cosines to solve triangles when you're given two sides and the included angle. Again, this is a corner of the triangle. Okay, this will assist in finding the third side that we've not been given. Okay, the second setup that I can give you is, again, I can give you all three sides. All right, and then you will get to pick which one of those three equations that I just presented to plug into. Okay, you can solve for angle A first if you want. You can solve for angle B first if you want, or you can solve for angle C. Okay, again, 100% up to you. Okay, can this join with the law of cosines? Yes, absolutely. Anytime you're using anything math-wise, if you can use another process to help encourage simplifying things, then by all means go ahead. Okay, so that's what I'm going to encourage you guys to do here. You'll use law of cosines first to find a piece of information. And then from there, we're going to go back to the law of sines and use that. Okay, so example 1 here, I give you three sides. So here, for some reason I didn't give you a triangle, so let me go ahead and give you a triangle here. Okay, side A, side B, and side C. Let's note that side B is the largest, so I'm going to put side B down here. So angle B, because this is the largest side, should be the largest angle. Okay, we'll call this, that would be B in red because I don't have it yet. We'll put side A over here. And we'll put side C over here, which would make this then angle C, and this angle A. Okay? So again here, I can use any one of those three equations that I so choose. Okay, so let's go ahead and go with the first equation there. The a squared equals b squared plus c squared minus 2bc times cosine of angle A. Okay, we'll make note here that we have all the side lengths, so everything in there is included information-wise except for angle A. So because I'm plugging into this equation, I'm going to solve for angle A first. Okay, if I chose the one with B squared in front, then I'd be solving for angle B first. Okay, or if I chose the one that has angle or side C first, then I would solve for angle C first. Okay, again, 100% up to you. Okay, and that means that your answers will vary very, very minimally as far as the decimals. Okay, 25 squared equals 52 squared plus 47 squared minus 2 times 52 times 47 times the cosine of A. 25 squared is 625 is equal to 52 squared, which is 2,704, plus 47 squared, which is 2,209, minus, and I'm going to go ahead and multiply these out, 2 times 52 times 47 is 4,888. Times the cosine of A. Okay, and again, using now order of operations, we're going to simplify this. So I'm going to take and add the 2704 to the 2209. That's going to give me 4,913. The rest of this is just going to drop down. Okay. Here, what I see a lot of times is people try to combine that 4913 and they try to subtract the 4,888. Please be sure not to do that. Cosine is multiplied by that 4,888. Okay, so we cannot do that. You have to subtract here from both sides. That's going to give me negative 4,288 is equal to negative 4,888 cosine of A. Okay, make sure that this negative trails down with it, or the subtraction. Then I'm going to divide both sides by that negative 4,088. 4,888. I said that incorrectly. Okay. And then I'm going to have to do what? Here, notice that I have to find the angle, and I have to get rid of that cosine. So I cannot just divide by cosine. I have to again now apply that inverse property. So here I'm going to have the inverse cosine of, we have two negatives, so I'm going to make it a positive. I'm just going to leave it as a holistic fraction here. Is equal to cosine inverse times cosine of A. Which again, what happens here with the cosine and cosine inverse is they cancel each other. So now angle A is about 28.69 degrees. From here then, as mentioned, you're going to go ahead and set up the law of sines. So I would have sine of that 28.69. Over the 25 should equal sine of angle B over the 52, which is equal to sine of angle C over 47. Okay, and again here, note that you have one fraction that is completely filled out. That's the first one. And then the other two are missing just one piece of information. Okay. you get to choose then which one you want to solve for. So here, since A and B are next to each other, let's go ahead and use those two. So changing my color here, I'm going to use these two. And again, I'm going to cross multiply. So I have 25 times sine of angle B is equal to 52. Times sine of 28.69. I'm going to divide both sides by 25. And again, here I have that situation where I have sine of angle B, so I have to use the inverse to get rid of that sine. So inverse sine of the sine of B is going to be equal to the inverse sine of all of this. So 52 sine of 28.69. Barely fit it on there. Divided by 25. Okay, so sine and inverse sine here are going to cancel. That's going to give me angle B is approximately, when you plug that in, you get 86.91 degrees. Okay, and like with any other problem, once we have two of the three angles, you can solve for that third angle by taking them and subtracting them from 180. So angle C is equal to, let's do approximately, because again now angle A and angle B are both approximations. So 180 minus the 28.69 minus the 86.91. So angle C is approximately 64.4 degrees. Okay, so three pieces of information missing, all three angles, and all three pieces found. Okay, again, visually just kind of pay attention to the fact that angle A is my smallest angle, and therefore the smallest side approximately across from it. Okay, angle B is then my largest angle, and side B is the largest side. And angle C is the one in the middle, and side C is the one in the middle. Okay. Final example for the video here. Okay, here notice that I'm giving you an angle and two sides. When you put this together, again, you should have a corner. Okay, so visually just looking at this, we'll call this angle C, and it's 85 degrees. We'll call this side A, and we'll call this side B. So I need side C, I need angle B, and we need angle A. Okay, with ones like this where you are given an angle, you have to use a very specific one of those equations. And you have to use the equation that matches the angle that's given. So here, because angle C is given, we're going to use the one that starts with C. Okay, so that equation was C squared equals the other two squared added together, so A squared plus B squared minus 2 times the, so A times B, times the cosine of angle C, so 85 degrees. And C there instead of 85. Okay, so then plugging in things that we know, so C squared is equal to 12 squared plus 35 squared minus 2 times 12 times 35 cosine of 85. So working that out now, we have c squared is equal to 144 plus 1,225 minus 840 cosine of 85. You're then going to add these together, so c squared is equal to 1,369 minus 840 cosine of 85. Again, here being very careful not to subtract the 840 from that 1,369 because the 840 is attached to a multiplication of the cosine of 85. So you cannot subtract those. Okay, so take 840 times cosine of 85. That's going to give me c squared is equal to 1,369 minus approximately 73.21. I'm going to subtract those two from each other. That's going to give me c squared is equal to 1,295.79. And then I'm going to take the square root of both sides. So c is going to be approximately 36 if we round it up. Okay, it's 35.997. Okay, so we round that up. All right, from here now, again, I can plug into the law of sines. So we go to that. So law of sines is sine of angle A, which we don't know, over side A, which was 12, equals sine of angle B over 35, which equals the sine of 85, or sine angle C, over the 36 that we just found. Okay, and again, you get to pick which two you work with. Again, we're going to use that one that's completely filled out, so the last one here. And we can use either A or B. Again, for the purpose of the fact that they are right next to each other, we'll just use those two here. And we're going to cross multiply. So I have 36 times sine of B is equal to 35 times sine of 85. I'm going to divide both sides here by 36. Okay, and again, we have that sine on that angle B, so we cannot just divide by sine. We have to take the inverse. So I have inverse sine of the sine of B is equal to the inverse sine of this stuff. So 35 sine 85 over 36. And again, these cancel out. So we have angle B is approximately 75.59 degrees. Okay, and likewise, now that we have two angles, we can find a third angle by taking them away from 180 degrees. So I have angle A is 180 minus angle B minus angle C. So angle A is equal to 180 minus, let's go back here, let's make angle A is approximately 180 minus the 75.59 minus the 85. And again, approximately here because of the fact that B is a rounded off decimal. Okay, so angle A is then approximately 19.41 degrees. Okay, again, if your decimals are minimally off, okay, I'm talking about in the hundredths place, okay, that would be okay. All right. Any questions, comments, or concerns? Again, by all means, please reach out to me and let me know.